All right, our next step here, we're going to go ahead and create our Niagara system and import our texture files that we created in Copernicus of our mesh splats, the 4x4 mesh splat variations. And I've also gone ahead here and imported our FBX fountain that we have available through the Fab library. This will give us a sense of scale as well of what we're targeting. And then again, if we look at just going into our sequencer and playing, we can see our alembic water is obviously too big. We're going to make that smaller as we build out these next steps. So we're going to go over to textures and import our mesh textures, our mesh splat textures. So let's go under our Houdini projects into the water fountain effects texture directory. And I'll grab both of those, the splash and the splash speck. And we can double click and open these up to look at the settings for these. We can see we have our 4x4 different splash shapes. And we can also look at these under HDR compression if needed, or just the default. Depending on your needs, you can use either. And the same idea with our spec pass. And we have all four, and we can again look at that either in HDR or just the default compression settings. So those are looking fine. We'll go ahead and save those. And let's now go over to the materials directory, and we're going to create a new folder. Let's keep things organized. We'll call this water splash is. So in here, we'll go ahead and build our material. Put down a new material. And this is going to be for these splash textures specifically. So we'll call them water splashes. And then we can go ahead and double click to go in. Splash is. There we go. And now we can go ahead, look into that, and double click. All right. We'll open up our window here on the material graph, and with that selected, we're going to go ahead and change our blend mode to translucent. And we can change this lighting mode to volumetric directional. And then if we type in our search area to be Niagara sprites, we want to check on. And then we can look at building out our parameters. So we'll start at the top here. And one of the main things we want to do is start to establish if we're going to have any color. Let's build out a color, base color. So I can hit 4 on the keyboard and click in the graph. It'll open up create our 4 vector for color. And I'm also going to hit tab and type particle color. So we're going to use these together by wiring in a multiply. And our multiply, we're going to wire out the color and our RGB from particle color. And that we can wire into our base color. However, we get an error, we're going to need to change that to a parameter. So we right click and then we can give it a name like base color. And this will give us a parameter for our material instance. Great. So now let's go, I'm going to grab our textures. I think I'm going to put these into a separate directory as well to keep it more organized. I'll just do this water splashes again. Grab those, move them like so, and jump into there. So with these, now I can grab them and drag them into our material graph. You could also just right click if you wanted to bring up that texture sample, but this is easier just to drag them back in. Now what we're going to do is convert these to parameters. So again, we'll have this flexibility, this proceduralism in our setup to change these textures on the material instance versus having to change them on this master material. I'll call this one spec texture and the other one can just be base texture. It's up to you how you want to name those, but something to distinguish them. So now I want to erode away these textures over the life of a particle. So I'm going to take the alpha and drag out a wire and type min, and that'll get us the 1 minus operator. I'm then going to wire in and add. So our alpha coming out of our particle, we're going to take 1 and minus that value, and that'll be what we wire in addition to a parameter here, just a float that will default to 0 for now. And from the add, we're going to put down another add. And again, if you hit 1, put down another scalar parameter. We're going to make this convert it to a parameter and call it something like erosion. This is going to be a value we're going to plug in with, say, 0.25, and that'll go into that B component. So now we're adding a little bit to whatever value is coming out of the alpha, starting with 1 instead of 0. Going back to that other add, we'll put down a smooth step and wire that into min, and then our other add will wire into max. So we're going between a min and a max value over the life of particles alpha, and we're going to use the value of these pixels, gray values. So we can drag out from RGB and type component. We'll want component mask, and that allows us to just choose which channel. Green is usually the preferred channel on an RPG texture, and wire that into the value. So that value is what we're going to affect in this smooth step. And then finally, we always like to have a little extra control. We'll put down another multiply and wire in another scalar value. So again, we'll make this a parameter that's exposed to the material instance and call this opacity. Give that a value of something like 0.25 again, and wire that in to the B component. Now that will go into opacity. So this now allows us to drive the opacity of our sprite by the alpha value that'll be on the particle for the Niagara system we're going to use it on. How this is going to look, we'll do a little test here. With a debug, if you type debug and choose times sign, this will go from -1 to 1 over the tick of the game. And we're going to wire this into a lerp operation. No, not add, but lerp. Get rid of that. So you can type linear and get lerp, or just Control or L and click on the material graph. And then we'll put the debug into B, and we'll put down another scalar, default value of 1, and we can put that value into alpha. So now we'll take the add from that wire coming out of particle color and feed that into A. So what this will allow us to do, if we display this now, we'll right click on the, actually sorry, we're going to lerp the value, and then we're going to wire it into the smooth step, both the min and this other add going to the max. Then we'll display the smooth step, and we'll check on real time. So now we can see our texture sprites are eroding away basically over time, and this is just a sine function going back and forth, but it'll erode over time of the life of our particle. So we can see that's working. That gives us a pretty good indicator that these textures have the right range of gray values, and the last part, the brightest part, is the last that remains as the sort of inner core of these. So we'll copy and paste these nodes and do the same operation a smooth step operation for the spec pass or the spec texture. That way it'll be consistent so that everything erodes away, both that base color and the spec, or what we're calling spec is really just fake specular we'll put into emissive. That all will go and erode away pretty much the same way. So again, we'll take this now with a multiply and wire that in, put down another scalar, make that a parameter, convert to parameter, and call this spec. And then we can, yeah, spec value is fine. Give that a default value. Maybe 0.5 is fine, 50%. And wire that into the B component. This now will go actually into emissive color. So again, this is going to be unlit. In that way, it's just going to be our fake rim light. We can rename our other erosion parameter, something like spec erosion, so we have some clarity. We apply the changes and save this now. And then let's go back out to the editor. And we'll make a material instance of this material. So like before, I would like to change the name to MI and go ahead and save that. And we can look at the results here. We can see our settings for the global parameters we can expose. And then importantly, we can see we could change our textures here and reuse or make more of these material instances to use with different textures. Okay, so that's looking like it'll work pretty good. Let's jump over to the systems directory. And I've already created a Niagara system. We can double click and look at, we're going to modify a few settings here. But this is a pretty straightforward one emitter system. I'm just showing, displaying some default render sprites just to get a sense of the behavior of what we're doing. This is meant to be, again, the splashy elements coming off of the main mesh, either the Alembic or the VAT version. And I like to see these play in a level, so we're going to show here, we'll drag it into the level and have a better view of how it's responding. But for now, let's jump back into this and we'll go over some of the settings and explain how we're going to use these user parameters. So we're just doing a spawn rate, and what I've created is a number of these float user parameters by hitting the plus arrow. And so in doing so, you can create a parameter, give it a name, and give it a default value. And I built a few of these already. I'll just make a quick one here called TMP. But I want to be able to have these available on the actor, the Niagara actor, these settings. So these parameters, these user parameters, are now all available for each individual actor in the level or in the blueprint. So that'll be useful. And it's a procedural way to do this. So we'll go to our initial particle and we're going to start swapping in these user parameters. You just click and drag them over to the component you want to modify. And I've named these to be the same name as what we're swapping them out for. So we'll change up our life min and life max. We'll change our sprite min size and sprite max size. And now all these components will be controlled by those parameters. And now again will be per actor in a level. So again, you can see we'll do the same for the shape of the sphere radius. We can modify and keep that flexible with a user parameter. The spawn rate, same idea. We'll do that, drag it over. And these are all going to be pretty straightforward. One thing I did a little differently here in adding velocity, I wanted to have a velocity speed that's a min-max, so I added a random range float into that. So some will have this minimum value, and they can't go past their maximum. The other thing I like to do is have a origin from point, that vector, control what direction the particles are going to be flung out from. And so again, this would be in the particle system space simulation position. So typically I'll move particles along the x-axis. But this is something you can change, again, with this parameter very easily on the actor once you have it set up in your level, in your scene. I'll delete that extra one I just made as an example, and now we can go into our particle update stage. Here I like having rotation on these sprites, and so I gave them basically the ability to rotate clockwise or counterclockwise by multiplying one of the values by -1. And then again, I can use that rotation rate parameter to swap out what basically is going to be the speed or the rate. The sprite size, I almost always have this over the life, normalized age, lifetime of a particle, so it grows. And then likewise, the alpha of the sprite. I'm keeping that connected to normalized age. I'm keeping it steady until 0.5, half of the life, and then drops off. Gravity and drag I've played around with just sort of in relative terms. Again, that's up to you depending on your setup, how you want to modify or influence that. So now if we go and look at this plane in our level again, we're just looking at these default sprites. We're going to apply the material instance for our sprite render. And right off the hop, they're almost impossible to see, and that has to do with our settings right now for our material. So if we bring up our material parameters again, and we start to play around, we can see if we really crank up our opacity just to visualize these, they'll become more visible. And we can also tell right now, hopefully it'll be more evident in a second here, that we're not really cycling through those. Actually, let's play with our collision. Our collision is set to bounce, but we can change that to kill. So kill on collision is really what we want. We look under the surface here, they're no longer bouncing or falling through. They are dying, and that's what we're going to want when they hit the basin of the fountain. So kill on collision for our collision module. Getting back to our sprites, we want our sprites to cycle through those 4 values. And for now, they're not. They're stamping all 4 on every particle. So we still need to modify how the mesh, how this texture in the material, I'm going to make these a little bigger to see this, is being used. And like again, right now, we can just see there are 4 being stamped on every particle. So what we typically would do is we'd cycle through the UVs of the texture, and one of the things that default to that's set to is 1 and 1, but if we change that, it'll need to be 2 and 2, which again gives us our 4x4, and then we're missing a module that we need to choose between those 4 images, basically from 0 to 3. So if we go into particle spawn and hit sub, we want sub UV animation. I think I put down texture. It's supposed to be UV animation. And we'll change that to be random. So the animation mode is random. And now we can see there aren't 4 of them. There's 1. And it's picking between those 4 images on our texture. And each image is its own quadrant because we set that to be 2x2 in the sprite render module. So we can apply that change and save that. Now we're getting our sprites attached to our particles, and they're a little bit larger, we can see, and they're rotating. We're pretty good now with this system to then go to the next step, where we're going to build a blueprint. And in that blueprint, we'll be able to combine our Niagara system, our water mesh, and this fountain. So let's go ahead back to content directory, and we'll create that folder and call it BP for blueprints. And our next step, we'll go ahead and look at building that blueprint and these components to get us the final look.